So welcome to the new question where you have to count the Iceland. Okay, count the Iceland too. So in this question, what we have to do? In this question, the graph is variable. Graph is variable in the sense graph is changeable. So we just change the position of Iceland. Like if we change 0, 3, like initially, if we put 1 at the place of 0, 3, so it says that the number of count of Iceland is 1. Okay, when we put 1 at the stage of at the place of 1, 2, then it will say that the number of Iceland sorry, 1, 2 is not here, 1, 2 is here, 1, 2 is here. Okay, so it will say the count number of Iceland is 2. Okay, so we change the position of zeros to 1. It means we change the graph. We change the graph means we change the positions variably in the sense that we change the position, like we place 1 here, 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 and when we are going to count the Iceland. Okay, so we initially we change, if we put a 0, 1 at place of 0, 3, then it will count Iceland 1. Okay, if we place 1 at the stage of count 1, 2, like here, then it will count the Iceland is 2. Okay, so initially then the number of Iceland is 2, and after that when you put 1 at the 0, 2, then the number of Iceland is 1, because it makes this Iceland. Okay, so the number of Iceland will change according to change of this graph, according to change the graph. So we have to count the Iceland when our graph is changeable, when our graph is changed according to our positions. Okay, so how we can count this graph, how we can count the Iceland in this graph? So for count the Iceland in this graph, what we are getting is there are the position is changed according to our this array. Okay, so the position is changed according to this array. So every time our the number of the number of Iceland is changed according to position. Okay, so how we can figure out, how we can solve this question? Okay, so for this, what we have to do, you can use a brute force technique where you just put a 0, 3, where we just put a 1, 1 at the 0, 3, and we just go and find out how many how many count how many Iceland is presented in this grid. So initially we put 1 at the stage of 0, 3, and then we are going to count the Iceland. So it takes n times. So for everyone we takes n times. So this is take O n square time. So this will take a higher time. This will take up many times. Okay, so we are not going to use this algorithm. So we are going to use union disjoint theory, which is previously explained in the video. Okay, so you have to just go and watch this video. So how we can approach this question? So we are using a union disjoint theory. So how we can approach this question? So initially what we are doing, we just put 1 at the stage of 0, 3. Initially we put a 1 at the stage of 0, 3. So at the stage of 0, 3, we find out this is our Iceland. When we are putting any Iceland, then it will take count as a 1, because it, when we put Iceland at 0, 3, like this at this stage, then it will count Iceland 1. Okay, because this is not merging with anyone. And after that, when we put 1, because it cannot merge with anywhere, because it has 4 direction. The Iceland, how Iceland is made, when Iceland has 4 direction now. When it has 4 direction and no any Iceland presented in any direction, then it will not create any another Iceland. Okay, so 0, 3 is a single Iceland at this condition. But when we are going to put 1, 2 as a 1, like here, then also it cannot merge. Because this has 4 direction, and this Iceland it cannot merge with this Iceland. Okay, so it will count again 1. But when we are going to put, so this one and this one is pointing to itself at the stage of 0, 3. In union disjoint theory, it creates a set. This 0, 3, it creates her own set, because this will, which position 0, 3 is which position? 0, 3 the position of 0, 3 is 3. Okay, so at the stage of 3, what I'm saying, we are convert this 0, 1 position to simple 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. We converted the 0, 0 value into 0. This 0, 1, 1, this 0, 2 into 2, this 0, 3 into 3, using your technique of 2D matrix. Okay, so initially we put 1 at 0, 3, so it takes a count of Iceland. And when we put 1 at stage at the place of 1, 2, then it takes a count 1. Okay, and after that, when we put 1 at a 0, 2, when we put 1 at a 0, 2 at this stage 0, 2, then what we are getting? Then it makes pair with this direction, and also it can make pair with this direction. So this 2, initially 0 comma 3, like 3 will point itself and 1 comma 2 point itself. 1 comma 2, the position of 1 comma 2 is 7. But when we are going to put 0 comma 2 1, this 0 comma 2 1, then it makes a pair with this 1 and this 3. This 7, we have this position is 7. Then this 2, the 0 comma 2 will make a pair with 7 and also 3. Then it makes another pair. Then it makes another pair. This 2 makes another pair with 7. With 7 and also 3 also make pair with 2. So 3 can also point here. So it makes it decrease the value, because when two Iceland will merge, then it decrease the value. Why? This Iceland, suppose this is our Iceland and this is our also Iceland, then it makes a single Iceland, single Iceland. So if the second Iceland is here, then it counts as a 2, but this Iceland is shifted here, then it counts 1. Okay, because this Iceland makes the whole Iceland. Okay, so if two Iceland is near, is in 4 direction, is neighbor. If any Iceland is a neighbor of another Iceland, then it decrease the Iceland, the number of Iceland. Okay, so when 2 is presented between 3 and 7, then it decrease the number of Iceland. Okay, in 2 times, because 2 pair with 7, 2 makes pair with 3, so it decrease the value of 1 and 1. Okay, so total number of Iceland is 1 plus 1 plus 1 minus 1. Okay, so here is 1. Okay, but after that we got 1 at a 1 comma 4. So the position of 1 comma 4 is this. Okay, so this will take account 1. Okay, because this is a single Iceland and it is not connected with any direction. In this direction, in this direction, it doesn't get any Iceland. Okay, so it counts its own value minus 1. When any Iceland is 1, when any Iceland gets 1 value, then it takes 1. But because when any position says that there are an Iceland, and in the neighbor of this Iceland has no any Iceland, in any direction we got no any Iceland, then we take such a 1. Okay, and after that at a 2 comma 3, and also at a 2 comma 3 we place 1 here, and also in all direction he doesn't get any Iceland. Okay, so it takes his own count. Okay, so we increase the plus 1 again. Okay, and after that what we are going to do after that what happens? The other thing is also, when we take a 2 Iceland, we are not increasing the value. Okay, so we have to just increase the value, because when 7 initially when 0 comma 3 Iceland, then we take 1. When 0 comma 7, sorry, 1 comma 2 is Iceland, we take 1, and when 2 is Iceland, then it takes also 1, but it merged with a Bremer, so it decreases the minus 1. After that, when 1 comma 4 is Iceland, then it takes 1, and also after that 2 comma 3 is Iceland, then it takes 1. But after that, when 1 comma 3 is Iceland, when this 1 comma 3, this is Iceland, then it makes pair with here, and here. But these two pairs now is same. These two pairs is same, because this is same pair. This is the same pair, and if this is make pair with them, then it no need to make pair with them, because it creates this pair. Because it create this pair initially, then he does not require to create pair with 3. So it decrease only 1 times. When it make pair with here and here, but it should be decreased with here, because it creates the pair with these 3 values. Okay, so it does not require to create pair with 3, so it decrease only 1 times. But here it decrease with 1. It in this direction here he should be decreased with 1 value, because it is different with this pair, because this is a first pair with this value, and also here it makes another pair, and then it should be decreased with 1. Okay, so total we have 1 pair, which is this pair. Okay, so total we have this pair. Okay, we have this pair of Iceland. Okay, so this is total equal to 1. Okay, so every 13 and 19 will point at 7, because this will pair with 7 and 13. Okay, so because 2 comma 4, like this 2 comma 3, this 1 comma 3 will make pair with this, then it will point again here. Okay, so this is your explanation. I hope you understand what I'm saying. So I'm going to code it. Okay, so we are going to code it. So how? So initially we have to just put a base case. Okay, what is our base case? If n less than or equal 0, if n less than or equal 0, parallelly if m is less than or equal 0. Okay, so if n less than or equal 0 and m also less than or equal 0, so in this condition we have to just return result. Okay, in this condition we have to just return simple result. Okay, or after that what we have to just take int count equal to 0. This is for what? This count will 0 is tell us that how many number of counts of Iceland. Okay, what I'm saying, this is used to count this Iceland. Okay, this Iceland. how many Iceland is presented. Okay, how many Iceland? Like if we put 0 comma 3 as a 1, so this Iceland will count it, and this if we put 1 comma 2, then how many number of Iceland is presented? So we have to just count this Iceland. Okay, so after that, what we are going to do, we have to just go and put int roots. Roots is like a parent in the roots is like a parent. Roots is like a parent. Okay, roots is like a parent. M multiplied with n. After that, what we are going to do? We just take a size. We just take a size. Okay. We just take a size. Size. We just take a size. Okay. We just take a size equal to new int. In this, what you have to do? We have to just put m cross n. Okay. After that, what we are doing? We have to just put arrays dot fill roots comma -1. Okay. After that, what we're doing, we have to just go and put a direction array. Why? Because we have to move in all 4 directions. Okay, we have to just go in all 4 directions, so we have to put a all direction array. Okay, after that, what we're doing, we have to just put all direction array, new int like this type. Okay, and after that, what we're going to do, we have to just go and put the all condition -1 comma 0 comma 1 comma 0 comma 0 comma -1 comma 0 comma 1. Okay, so this is our all conditions. Okay, after that, what we are going to do, we have to just go and find out our all position in array. Okay, find out our all position in array. Okay, so what we have to do, we have to put for int all positions. Okay, int all positions array. Okay, int by p in positions in positions. Okay, in positions, what we have to do, we find out all positions. So after that, we just find out our root. Okay, our root of Iceland, roots of Iceland. In this Iceland, what we are doing, we have to just put Iceland. Okay, so after that, we have to just increase the size of Iceland plus. This is used for put a rank array. Okay, this is act as a rank array. Okay, so after that, what we are going to do, we have to just go and put out our all directions. We have to just go and put out our all direction. We just go and put out our all directions, and then you just go and take a int x. So this is our Iceland positions. Okay, but the something will change here. What is change? We have to just find out our all positions. Before positions find out, we are not converting our 0 comma 1 1 comma 2 in the normal 1 2 3 4 5. What I'm saying, we are not going to convert this 0 comma 0, this 0 comma 1 into simple 0 1 2 3. So we have to just convert this now. So we have to just, because we are going to put this roots in this Iceland number, you know, in linear disjoint theory now. So what we are doing, we just check this p0 multiplied with n plus p1. Okay, so this is our p1, and after that, what we are going to do, we have to just go in Iceland. Okay, in Iceland, what we are doing, we just check out our first int x equal to p0 plus dir 0. Okay, comma int y equal to p0 plus dir 1. Okay, And after that, what we have to do? We have to just find out our neighbor. According to this XY position, we have to just convert this into normal 1, 2, 3, 4, 5 because it comes with our row and column. So we have to just convert this into normal 1, 2, 3, 4. Okay. For this, what we have to do? We have to just x multiplied with n plus y. Plus y. Okay. Then what we have to do? We have to just check out our if if x is less than 0, x is less than 0 and x greater than or equal n, if x greater than 0 and y less than or equal 0, and parallelly y greater than or equal n, and roots of neighbor neighbor equal to minus 1. Okay, what we are going to do? We have to just go and continue at that part. We have to just go and continue because we are not going to add that part because we doesn't get any neighbor, so we have to just continue. We are not going to anywhere. When we are getting neighbor, we are just checking this condition. We are just checking that condition. If neighbor roots equal to minus 1, it means this will not come. This neighbor will come. This neighbor will not come. Okay. So at that stage, we are not getting any neighbor. Okay. Then if we get that part, then we are not going to do that condition. Okay. So this is our continue condition. After that, if we get any neighbor, then we have to just go and check out that what type of neighbor we are getting. Okay. So we have to just go and check our neighbor. Okay. Equal to find our neighbor. Okay, our neighbor comma roots. Okay, after that, what we are going to do? We are just taking int Iceland root equal to find Iceland comma roots. After that, if is land root is not equal to neighbor neigh neighbor roots. Okay, neighbor roots. Okay, if we are not getting any roots, if our roots is similar, if our root is not similar also, if roots only, it means if our parent is not same, it means in disjoint theory we are taking a parent, but here we are taking just roots, simple, because the solution code is in this form, so just we are taking this form. Okay, roots. Okay, so if our land root and this root is same, then what we are going to check? If size of each Iceland size of each Iceland root, size of each Iceland root is greater than, I think we have to just put this bracket, size of each Iceland is greater than or equal size of neighbor neighbor root. Okay, so what we are getting here is this. Okay, so size of each Iceland, so what I'm saying is, so I think size, this is not okay, so this is nothing, right? Is Iceland root. So if this condition will true, then what we have to do? We have to just go size of Iceland root will plus equal to size of neighbor neigh root. Okay, roots in the neighbor roots. Okay, so this is our conditions. After that, what we are going to do? Let us go and we have just put roots of neighbor, NIGHBOR, neighbor root. Roots of neighborhood. It means parent. It means parent equal to Iceland root. Iceland root. Okay. After that, what we are going to do? We have to just go and if else, if this is what we are going to do, we have to just go and put size NIGH NEIGHVOUR root. Okay, so never root up size. I think we are not going to put this. Okay, so that condition, I think never root plus equal to size of is land root. Okay, if size is plus equal to, okay, so in this else condition what we're going to do, we have to just add the size rank. Okay, then what we're going to do, we have to just go and put I size of this land plus equal to neighbor root. Okay, after that where what we're going to do is just return, we'll just count minus minus. Why we are just putting a count minus minus? Because at this stage the the neighbor is merging with its parent. Okay, because at this stage because at this stage the neighbor is meet with our parent. We have to just add answer at not at this stage. We have to just add answer at this stage. Answer dot add count. Okay, so we are just going answer dot add count, and this is your for loop. Okay, so this is your for loop, and then just remove this for loop and we just come here. Okay, and this is our for loop, and then after that we have to just put this for loop. Okay, so we are going to check that the code is good now. Okay, so I'm just explaining the code again. So what we are doing it, we just take m less than or equal 0, n less than or equal 0, then this is our edge case that if we got 0 in 0 position, then it should be written 0. Okay, so we are taking our roots and we are taking our size, and we just fill out our arrays with roots and minus 1. Okay, and after that we are just find out our positions like 0 1 0 1 0 2 0 3 to convert it into 1 2 3 4 5 6. After that we just increase the roots. After that we are just find out our roots parent. We are using union disjoint method. We are just going to find out parent. Okay, so after that we are taking all directions for our every nodes, our every Iceland. Okay, and we are going to on all 4 directions from this part. If our direction is not valid, then we will continue. And after that we are applying our unit disjoint method theory that this Iceland will come in which pair. We are checking at this stage. If we make any pair, then we are just decrease the count, and after that for every position we are just add this count. Okay, so this is our answer. Okay, so we are just going to submit it. And then to submit it. So this is submitted. So thank you.